regression actually. Logistic regression is a classification kind of problem, and it's basically today's example will be very simple. We'll work with the Boston data sets, and we will just do a simple classification of yes, no, or 1, 0, this kind of thing. And later classes, we will show how we can do multi-level classifications kind of problem. But today's problem, we want to stick with very simple thing, but we will cover a lot of things. We will use sklearn package. We will do train and test split. First, we'll import the data, then we'll use train and test split. We'll do the training of the model, then we'll do the prediction, and then we will figure out all the different metrics like accuracy, recall, precision.
So we are dealing with the logistic regression. First of all, we are importing all these packages. We need NumPy, we need pandas, math package. Probably we don't need the math package, sorry. We need the logistic regression because we are bringing it from the linear model. We are using this breast cancer data sets. We will do the train test split. So, and also we will produce all this metrics. So we need all these packages. We are bringing the data. This data is actually available within this package. So we are just calling that and bringing that data into this variable. Now, this is kind of a key value pair data set. So we are first checking what are the different keys are available, and we can see the data target is available, and also the feature names is available, target names are available. What we are doing in this step number 4, we are basically just adding the column name to the data and producing the data frame. So this is creating the data frame, and we can see that we have 5 rows, 30 columns, and because it's already a pre-processed data, so we are kind of assuming there is no null values, no need to do any kind of pre-processing, because our intention here is not to do exploratory data analysis or feature engineering, not like that. Our intention here in this class is to show how we can use the sklearn package for logistic regression. One more step is basically we are just adding the target column into the final data frame. So this is like our final data frame looks like. We have all these features and we have the target column. Cool. Up to this, nothing special we are doing related to logistic regression. Only thing now, just by seeing this data, you can understand that we have to classify this data so that it will check whether it's a 0 or whether it's 1. Splitting up the data into X and Y components. So basically we are making independent features and dependent features. Clear up to this? If it is not clear, don't forget to email me. If you are interested to learn with me, please email me. I'll try to help you. Train test split, what we are doing, whatever data we have, now we are splitting into 2 parts. One is the train, another is the test. We are bringing the logistic regression classifier and assigning it to the classifier. Also, this is little bit probably new if you are not familiar with this, but grid search CV is very important, like when you have different hyperparameters. And for logistic regression, we have some of the hyperparameters which we can tune. So by chance, if you are interested to know more about this, there is very easy way to check it. Actually, just if you do a shift tab and just click on this, you will get the complete information. So basically, what are the different parameters are available, and they are corresponding descriptions, and everything is given here. Okay, different kinds of penalty, L1, L2, all those things are given here, and you can play with this. Right now, for our example, I don't think we need anything, but there is an option to play with this, and especially this is good to know because sometimes when we'll work with other models, it is very important to understand which hyperparameter is helping you or which hyperparameter you need to tune. Okay, so just for our purpose, we make this for understanding. So grid search CB, what it will do, it will basically try to use the train data and try to predict the best parameters actually for the training data, and it will produce that model. So we are calling, we don't need this line, so we are deleting this, and we are creating a grid search CV object. Okay, grid search CV is available into the model selections because this is the way we have to select the best model actually. Okay, and what we are passing the classifier, which is nothing but the logistic regression. We are passing all the parameters. Scoring, in our case, because we are not dealing with the imbalanced data set, so we are just focusing on the accuracy. But remember, in our next class, when we'll discuss about more on the imbalanced data sets and how to work with the imbalanced data sets, then probably you have to think about the right scoring or right scoring metrics. Okay, now you will basically use this object to fit with the trained data, and it will run 10 different models. Why 10? Because we have two different combinations here. We have two different combinations, and we have the cross validation equal to 5. So this is very important. This is the way you can get the best model. So cross validation and the hyperparameter, both we are showing in the same example. So it will basically run, it will create 10 different models and select the best model for you. Okay, so this is the way it's ran. And then if you want to understand which is the best parameter or which is the best score, you can get it very easily. There is another way, you can just put the result into a data frame and check. So it will show you the grid search CV first run and the second run, and within that it has the 5 different cross validation. Cool. Once this is done, so now you have the final model ready, so which is this one. Now you will use that final model for predictions. Now one way to capture is basically ROC curve, and if you just follow this code, it's very simple code. Basically we are doing the model and we are doing the predict proba. Now why predict proba? Because we want to capture the probability, not basically 0 and 1. We are exactly capturing the probability, and then we are using that probability with a threshold value of 0.5, and then we are plotting this. So this is our ROC curve, and ROC curve looks good because ROC curve for this, if the curve is like this, then it is good because our true positive rates are increasing, which is a good sign. Okay, and also what we are doing, we are generating the classification report and the accuracy. Now on the test data, accuracy is also good along with the trained data. So that's mean it's a good model, because sometimes what happened, like your trained data has a good result, good accuracy, but your test is not that. That's the condition of overfitting. Okay, but in this case we are not such a scenario, and also we are generating the classification report, which is telling all these numbers are telling a very good indication that this model is good. So precisions are, recall is almost 0.99, which is really good sign actually for one. F1 score is good, so all these values are good. So this model looks good, whatever we did, whatever the way we did the grid search CV and cross validation, everything looks good. And this is kind of the sample step to implement any logistic regression um, classification kind of problem from the sklearn package. Thank you. If you like it, please just give a thumbs up or try to subscribe. I'm building such models or such videos almost every day. I'm also learning. My goal is to help other people. If they can learn, I'll be very happy. Thank you so much.